Okay, should we get going then? So thanks everybody for today. Before I ask the three groups to report back, very important announcement about tomorrow, which Claire has asked me to share with you. So between 10 and 11, we will be joined by Bruce White, a former student union president, and hopefully a little later by a retired Welsh Assembly member who works on social care and the COVID-19 response. So the idea is to do this in the morning, and then we'll send people to a separate room. Well, we'll send these people to a separate room, and then those who want to can join them. So similar to what we've done before. So just bear that in mind. And I guess we can remind you all. Claire, we'll all get together at 9:30 again before going to the rooms. Yeah.
Yeah, we'll do that. And just to say, I don't think we've got. Yeah, Gemma is here, but Ed has been in touch with Gemma's colleague Parvel. Is Parvel male or female? Sorry, Gemma.
Parvez is male.
Parvez, sorry. So he is now able to join us between 2 and 3 tomorrow.
Okay.
So it was Charlotte, I think, that came. I can't remember. It's either you or Charlotte that came back. So we'll do the same tomorrow afternoon. We'll pop him into a separate room.
Yeah, and just to remind me, tomorrow we have presentations at 4. Is that right?
3:30 tomorrow, Chris.
3:30.
3:30 to 4:30 tomorrow.
So each presentation's about 15-20 minutes long.
Yeah, and then obviously any time for discussion and final points that people want to make.
Okay.
So, but we'll at 9:30 tomorrow. We'll just go through. We'll remind everybody the sort of timescales again as well.
Okay. All right then. So I guess perhaps if Chris's group would like to report back, I think, but by the sounds of things, we were just all together a minute ago. There's been some good stuff done today. And Emily's been brilliant at finding some really super duper research papers, which we will.
As have you, Jane. So don't.
I try to help. I'm a naturally nosy person, so I'm quite good at researching and digging things out. So I try to do my bit. But I'll leave you guys to it. To perhaps, I don't know if Emily wants to talk about the airborne transmission in the waiting rooms area, or who wants to do it for your group.
Well, if I just give a quick overview of the whole thing, and then individual people can talk about the individual bits. So we basically split the problem. So this is the problem of people moving around in buildings into a number of sub-problems. So sub-problem 1 is to look at what happens in a single room. So students in a single lecture theatre, probably in some sort of small group teaching environment, because if you take a lecture theatre, you have to divide by 10 the number of available seats. So here we have a lecture theatre which has 160 seat capacity, but will only take a group of 16 on that basis. So that was the first thing that we're looking at. Next thing is a kind of a sort of static issue, which is basically to say, well, if you can only get a certain number of students into a room, let's say maximum 25, how does that pan out against the room availability? So this is an optimization knapsack type problem, and Gemma's given us some data. We'll talk about that in a second. Third was to look at the impact of divide and conquer. So there are a couple of fairly easy to get your head around strategies which will certainly reduce risk. One is to just teach for longer in the same room, so that reduces the amount of movement around. And another might be to have half the rooms designated, let's say, as first-year rooms and the other half as second-year rooms if you've got a 2-year university, and then teach at different times, so that reduces that. Then we were joined by Nikolai from Bristol, who is an expert in crowd modelling, and he's produced a series of articles which need to get our head round, and some plots showing the impact of bottlenecks in lecture theatres, going into lecture theatres and coming out. So we're going to be having a look at the impact of bottlenecks and how that affects getting into lecture theatres and out of lecture theatres. And finally, Nick's been having a look at essentially the risk of impact to staff and how that depends upon things like the age of the staff. So if you're ancient like me, then the risk is much higher than if you're a student. So that's the various things that we've been looking at. So Emily, do you want to say a bit more about the aerosol side for the single room?
Yes, so we found a study that had used a stochastic Monte Carlo model to analyse the transmission of airborne infection in a hospital waiting room, and actually the size was comparable to the lecture theatre that Chris has just put up. And in the study, they were able to vary the occupancy levels of the room, the waiting times, so comparable to tutorial time, and ventilation rate. And the SI model has conveniently an exact solution, which is the Gamet-Honey-Nucci equation. And they use this to predict the probability of individuals becoming infected, which is based on the quanta production rates for various diseases. So in the study, they looked at influenza, TB, and measles. So I had a look around to see whether I could find any quanta production rates for COVID-19, and these have been estimated in recent studies. And they're shown to vary dependent on activity. So for example, whether you're breathing, speaking or singing results in different levels of infection. So we thought this could be just a kind of a good model for getting very quick estimates of the likelihood of infection depending on tutorial size, which will differ significantly depending on whether there's a 1 metre or 2 metre rule in place, the tutorial duration, as well as the ventilation in the room. Yeah.
Thank you, Emily. And also following on from the seminar that we had this afternoon, we're looking at the impact of surface contamination, bearing in mind that one thing we learned from the seminar was when stuff gets onto a surface, it tends to hang around for hours, and therefore there's not much you can do about mitigating it by not using lecture theatres for, you know, essentially once it's there and has to be cleaned off. Mandy, do you want to talk a bit about the static, the allocation stuff?
Unless Gemma's back, because it was Gemma's data. Okay, well, Gemma got some data from...
Well, just...
Hi. Sorry, it's my data, but please go ahead. I mean, it's not perfect data by any means either. So.
Okay, so Gemma's got some data about a week's worth of lectures and tutorials that happen at Warwick. So the whole sort of, all the teaching episodes, how many people are in there, how long the sessions are for. And she's also got the room, how many rooms there are and the size of the rooms. So we're just looking at, okay, if the rooms used to take 500 and it's a tiered lecture theatre, it'll now take 50 students if we use the 10% rule. And then if it's a flat floored, we divided to reduce it by to 30%. Given that's the room capacity now, what can we do with the existing pattern of teaching? So the first thing we're going to try is, well, can you do everything apart from lectures? I suspect, looking at the numbers, we don't think we're going to be able to do that. So then maybe thinking, well, what if every module had at least one face-to-face session a week? Could that be done? And given that you'd say something like the maximum size was 25. But once you've shrunk rooms because of the risks attached, you don't have many rooms that are bigger than 25 anyway. So the number you put as your highest number isn't really going to be affected. Anyway, we're in the middle of working through those numbers.
Thank you, Mandy. And thank you, Gemma, for giving us some hard data, which is really useful. Nick, did you want to say anything about staff?
Yeah, just very quickly. So I was looking, and it was a bit harder than I expected for just some raw hard numbers on things. If we assume just for briefly that students are up to the age 24 and staff are over that, then the risks for staff of catching the infection and dying are between 3 and 4.5 times higher than for the students. There's some data on BAME, which suggests that actually it may not be an issue in universities. It seems to be that they're more likely to catch COVID, but they're no more likely to die from COVID once in hospital. So we might have a benefit there. And quickly, in the rate in the population, currently today, about 1 in 2,000 people are infected based on the ONS surveys, the PHE surveys, which means most universities will have infected people in them. But just 4 weeks ago, that rate was 1 in 400. So as long as the rates stay low, we're okay, but the situation could change within the space of 1 semester.
Okay, thank you very much. Well, thank you, all the rest of the team. So that's where we are in group 1.
Okay, so Lars,
Okay.
would you like to go for your group?
Yes, thanks. So group 2 is split into 2 subgroups. Subgroup A, let's call it that way, deals with the question of how to design bubbles. And the subgroup B deals with everything that happens on, so the flow of students on campus once they have left the building. Yeah, so once they have left the building, what happens? How do we have to think about the flow? And I suggest that one of the group A maybe talks about what they have done. So Jess, do you want to go, or Tristan, or Jess, you're muted at the moment.
I know.
Okay, sorry.
So if Tristan would like to, he's welcome. I'll give him a couple seconds to shout that he wants to, and if he doesn't, then I will. No? Okay. So we're, I think I've mentioned a couple times, we're quite lucky on this sub-team to have a lot of expertise that's really specific to the questions we're addressing. So Tristan in particular is the lead author on a paper related to this question outside of the university setting. So this idea of the impact of social bubbles. So what we've been trying to do today, I suppose, is do some coding to work up some of our respective models to adapt them for the sort of questions that we want to address. The questions we identified yesterday are mostly about how do you devise a scheme, I guess, for setting up these bubbles, perhaps in a kind of hierarchical way, so that as prevalence goes down, you can interact with bigger groups of people. But if a case occurs, then you go back to your smaller groups. So we're looking at that question, how that might interact with testing, because one of the complications is that within this demographic set of students, at least for many of them, they're very unlikely to get symptoms. So the normal testing system, which is triggered by symptoms, is not going to work in this setting. Will there be any testing? So we have a lot of questions that we're still thinking about. I made a little list. I put some stuff in the HackMD, but I'll just read them. Which students are universities thinking of including in a bubbling scheme? Only freshers? Only freshers living in halls? Everybody living in halls? These are fairly different questions. So we're still, I'm sure that nobody really knows the answers to those, but anybody who has a better idea than us would certainly be welcome if they would share that. Are universities considering a testing regime? Or are they going to essentially wait until staff members get sick and therefore get tested to detect the illness in students? Sorry.
I can tell you something about Cambridge, just very briefly. Sorry to interrupt, Jessica, that we had an announcement from the VC recently. I'm sure Claire saw it as well, to say that they were making testing for all staff and students, I believe, available, but for people displaying symptoms. So your point about a lot of the student cohort not displaying symptoms is a very valid one, of course, isn't it? It's how can you test? You won't know to test if you haven't got the symptoms.
Yeah, you would essentially have to test them in a systematic or random as a surveillance thing. So that's a thing that I think we'll get onto tomorrow, modeling sort of how dangerous it might be in terms of outbreak size to allow the outbreak to spread to a point where you get staff illness, or you hit a student who is unlucky or has some other reason. So we've been thinking a lot about that. Gabor has been showing us distributions of data from Bristol about how many students live in different settings, which let us have an idea of, is it even a sensible thing? Because we really think this idea of bubbling really doesn't, we can't come up with a way that it works if you don't control student housing. So if you're talking about students that live off campus, then we don't think it's really a sensible thing to consider. But at least the data from Bristol indicates that there are a lot of students who live in halls or something like it. So so that doesn't immediately invalidate the questions, I suppose. And yeah, that's quite a lot of talking. Anything that Tristan or Gabor or Helen want to add really quickly?
No, I think you summed it up well, Jess. Thanks for doing that.
Yeah.
Good. Thanks. So that was sort of one group. The other group deals with the flow of students on campus. I will try to summarize a little bit, but please, David, Tina, I think Alan is not here at the moment. If you want to join in, please let me know. So we are thinking about what happens once people leave the building, or sort of this is essentially where our sort of modeling starts. So the goal is to come up with a model that prevents essentially choke points on campus. And we are asking the questions for us, is it viable, what some people have been discussing, adjusting the timetable to prevent sort of people getting sort of into congestion on campus. So by saying, well, let's start a little bit earlier, a little bit later with other classes, do we prevent congestion? And Alan, and that has been said already by group 1, had then asked Nikolai from Bristol, I think, yeah, to come in and give us some ideas. And we think that for the type of models that we do, a macroscopic approach is acceptable. So treating essentially looking at density of people on campus instead of using, say, an agent-based approach where you have to model each person on its own. Whereas, say, an agent-based approach might be of more interest if you are indoors, where really every person counts and you have much less space. And so at the moment, we have started with the toy problem to set this up and write down equations to start simulating some stuff on a toy model to see how this will interact. Yeah, that's it so far.
That's great. Really, really good stuff. Thank you very much. Ed, would you like to report on your group?
Sure. So apologies if my internet doesn't work too well at the moment. I think we're having a thunderstorm and that always seems to affect it. So we had one group looking at transport. We actually looked at that mainly this morning. Kieran has been getting some good data about the extent to which public transport capacity is reduced by social distancing measures. A lot of it seems to be estimates rather than measurements at the moment. I think that will change soon. So for universities, there are many different situations. City centre universities and campus universities have very different transport requirements and different responsibilities to take care of their own transport. We've been looking into how timetabling will affect the demand for transport, and with other people, we had a very interesting conversation with Joey Mickelwright this morning, who's a university timetabler at the University of Warwick. Basically, it's such a challenge to get a working timetable at all that they're not taking into account the effect of what they do on transport demand at the moment. Nevertheless, it does look like under the new way of working, the demand for transport will be greatly reduced. One of his working assumptions was that individual staff and students would want to minimize the number of days on which they travel to the campus. I hope that is true and it's something that could be taken advantage of. Okay, so we're still working on trying to produce, I think, something like a flow chart where university managers would be able to understand what data they need to collect and which people they need to get talking to each other in order to be active about managing their transport requirements. And of course, if the 2 meter distancing rule changes to a 1 meter distancing rule, or the recommended advice for social distancing on public transport changes, then that will change things. Now, the bigger question that we've been looking at is universities acting as hubs or sources of outbreaks which spread into their wider communities. So Kirsty Bolton has been setting up a very simple model to try to look into how individuals who are present every day on a university site interact with people outside the university community and how they interact in different groups. I wonder whether you would like to give a quick description, Kirsty.
Well, yeah, I can try. So we're trying to think of the simplest model that would describe some of the structure of how people mix, as well as how they interact with the broader community. And one idea we have is to adapt models that use for flu, for example, where you capture people's membership of households, membership of buildings, how many buildings they go to in a university a day, and membership of social groups, which may be as broad as a year level or as small as a bubble, but considering members of their households that aren't members of the university, how quickly or how often will they be infected? And also as another group, considering people who share transport services and the role that has in seeding outbreaks into the broader community. So we're, I mean, these will be toy models. I don't, maybe if anyone else knows of any good contact data for universities, maybe I haven't been able to find any, but I'm guessing they won't necessarily be relevant in this situation anyway. And this model could possibly describe some of the simpler restrictions that might be put in place, such as, you know, limiting which buildings you can use or group sizes or that sort of thing, or if you can divide buildings into two, so you're sure that this half of the building is not interacting with that half of the building, and you can incorporate that into your model of infection risk of people mixing in a building. So that's what we're looking at there.
Okay, thank you, Kirsty. So we've drawn a sort of schematic diagram of types of people who are present on a university site and the types of interaction that they have. It's a bipartite graph with activities on one side and roles on the other side, and that's enabling us to see which kinds of interactions universities will have control over and which ones they don't have control over. One thing that I'm particularly concerned about is, following on from what Nick, I think, said, the risk to the older age group, over 70s, from COVID is so very much higher than the risk to typical working age people, let alone typical student age people, that in fact the issue of controlling COVID on university campuses is very much about the corporate social responsibility not to be a source of large outbreaks which then affect the surrounding communities badly. So understanding the extent to which it's possible to reduce the contact between the university community and the surrounding community is interesting, but I think it's going to be so hard to reduce that actually universities are going to have to think very carefully about how to make sure they keep track of what the infection status is on their campus. So I know lots of universities are thinking about offering testing to their staff and students. And I think that's a very good idea, not just from the point of view of keeping their staff and students safe, but also keeping the surrounding community safe. Nick, did you want to come in on that?
Just that it's exponential, so it rises very rapidly over 65.
Yeah, so that's where we are in group 3.
Can I ask a question based on in part related to what Ed's just said? Where does the output of this work go in the first instance? Once we've finished writing reports and stuff, where will those things be put? Who will have access to them? And this is important for what I'm about to say. Is Matt here, or does someone else want to comment on where these works actually end up?
So I'll just and then what else? Ed or Chris might want to.
So
So I can say what happened with the second virtual study group that was run. So there was a report that was sent directly to the problem provider, but then in the interest of transparency, we very quickly produced a public version of that report, which was made available on the was it on the INI website?
It was made available on the KTN website, and ICMS website.
Yeah, with various links.
I also was put on the RAMP website as well.
I was just saying, since then we've set up, so it's been running since March, but we now have a website for that. So this, when this report is finalised, that will be so that will as well once it's as a public version of the document.
Yeah, and I imagine the report this time is going to be very much about not the results of modelling that we've done, but just to make people aware of the fact that modelling specific to their university is possible.
So the reason I ask this is because with this particular final line of investigation that Ed described, which I think is extremely important, probably one of the most important things that's happening here. So looking at how a university might inadvertently become a massive source of COVID infection for a surrounding community. There may be some very quick and hard political pressure if we sort of are able to model and say, look, you know, there's a decent chance that a university might become a COVID source. And this is different to the case of care homes, because care homes are quite self-contained. University students aren't self-contained and whatnot. So if universities become a source of COVID, firstly, universities are going to be very angry with this sort of a statement. They may not be terribly happy to hear that mathematical modelers are suggesting that universities could actually happen, and they may try and say and do things, say, oh, but that's just hypothetical modeling. No, dismiss. If a journalist finds that sort of modeling and it's come from respectable entities like the INI and ICMS, they may jump on it and splash it on the front page saying, oh my God, universities are going to kill us all with COVID because there'll be hotbeds. So as well as doing the modeling, we have to be extraordinarily mindful of how this is conveyed and communicated. I can already see two entities that might be either aggrieved or enraged at the sorts of outcomes of such work. So while I think it's probably one of the more important things that's happening here, to communicate that is a delicate issue, and not one that can be solved by just posting something on archive, so to speak. A bit of care needs to be taken about how it is. I don't know exactly how one would do this, and this is why I was asking where these things go. But a bit of care might be needed to communicate this in a responsible way that doesn't cause hype or an unwanted or unproductive response from either the university sector or the media.
If I can reassure people, I mean, we put a lot of thought in the last one of exactly how we presented and the care that we did with that, and I can see the equal amount of thought must be done. The other thing is that we wouldn't dream of doing anything without consulting everyone else. I mean, last time with the report, it was circulated around all the group, and that everyone had a chance to put some input in. So we are extremely mindful. I mean, these are, as you know, it's very easy for the press to run off with things, and that's something we have to be very mindful of.
Yeah,
I would say as well that that sort of dissemination and communication aspects of this, and it'd be really, really good points, Morris, are super important. So tomorrow, hopefully, when we've got Matt back, as well as Chris and David Abrahams, this can be discussed more, and probably would be good to be discussed when we pull everything else together in the participant catch up and final catch up at the end of the day. So yeah, some really good food for thought there, and everyone, we should discuss that some more tomorrow. So perhaps if we pull everything to a close, just to remind everyone, informal kickoff from 9:30, then group work from 10. And again, just to remind everyone again about the other people who will be joining, Bruce White, former Student Union President, and possibly someone from Welsh Assembly who works on social care and COVID-19 response, will hopefully be joining us between 10 and 11 tomorrow. And again, they'll be put in a separate room and people can go and join them if they want to talk to them. Then I think there was something about Parmes joining in the afternoon. Again, Claire and Lissy can alert us to that, and probably a similar arrangement will happen. Claire, is there anything else you want to say, housekeeping administratively?
No, I think that's it.
Chris?
I'll just very quickly to say we're going to post up the seminar we had earlier today about surface contamination, and there's lots of good stuff in that, so we'll be posting that one up as well.
Sorry, Claire, were you going to say something else?
I might have been, I've forgotten it, so no, I don't think so.
Okay.
So we'll start at 9:30, but the room will be open from 9 if people want to come earlier to get on with bits and pieces.
Okay, thanks Claire. Thanks everybody. See you tomorrow. Have a good evening.
Thank you, and you.
Bye-bye.
Thank you. Bye.